What if I told you that you're never truly at rest, even when you're sitting perfectly still? A curious question, isn't it? Today, we delve into the intriguing world of motion and rest. Now, you might be thinking, I'm at rest when I'm sitting still, and I'm in motion when I'm moving. But what if I told you that's not entirely accurate? Rest and motion, as we commonly perceive them, are not absolute states, but relative. What does that mean? Let's simplify. When you're sitting in a car and it starts moving, you feel the motion. But once it maintains a steady speed, you could sip your coffee, flip a page, without feeling any different than if you were sitting in your living room. To you, inside the car, it feels like you're at rest. But to someone standing on the sidewalk, you're in motion. This relativity of motion and rest becomes even more fascinating when we consider our planet. Earth, our home, is never at rest. It spins on its axis, orbits the sun, moves with the solar system, and even with the entire galaxy. So, even when you're perfectly still, you're moving along with the Earth at an incredible speed. Now, this doesn't mean you should hold on to your chairs to avoid being flung into space. The laws of physics work beautifully to keep us grounded, but it does change our perspective. It makes us realize that our understanding of rest and motion is based on our point of view, on our frame of reference. So, the next time you think you're at rest, remember, you're actually moving at a speed of over 100,000 kilometers per hour along with the Earth, scene script. Ever wondered why the laws of physics work the same way no matter where you are or how fast you're moving? That's the principle of relativity for you. Let's delve deeper into this. The principle of relativity is a cornerstone of modern physics, a fundamental idea that underpins our understanding of the universe. It's the assertion that the laws of physics are the same for all observers who are not accelerating. This might seem obvious, but its implications are profound and far-reaching. Think about it this way. If you're sitting in a train that's moving at a constant speed, you can still do all the things you'd normally do. You can read a book, sip your coffee, or even play a game of chess. The pieces don't slide around the board, and the coffee doesn't slosh out of your cup even though you're moving. This is because, inside that train, the laws of physics are working just as they would if you were sitting at home. The train to you appears to be at rest. Now let's add a twist to this scenario. Imagine you're holding a ball and you drop it. What happens? The ball falls straight down to your feet, right? But what would an observer standing outside the moving train see? They would see the ball following a curved path, moving forward with the train as it falls. So, who's right? The answer is both. From your perspective inside the train, the ball falls straight down. But from the perspective of the observer outside, the ball moves in a curve. Neither of you is wrong. You're just observing the event from different reference frames. This is the heart of the principle of relativity. The laws of physics are the same in all inertial frames of reference. In simpler terms, whether you're sitting still or moving at a constant speed, the way physics works doesn't change. It's only when you start to accelerate or decelerate that things get a little more complicated. But that's a topic for another day. So, why is this principle so important? Because it allows us to understand and predict the behavior of the universe. Without it, we would have to account for the motion of every single object in relation to every other object, which would be an impossible task. But with the principle of relativity, we can simplify our calculations by choosing the most convenient frame of reference. In essence, the principle of relativity tells us that there's no preferred stage for the laws of physics to play out on. They work the same, whether you're on a speeding rocket or sitting at home. It's not just about physics. The principle of relativity has profound implications for how we understand the universe and our place in it. Now, let's delve a little deeper and explore the true impact of relativity. At the heart of this principle lies the understanding that there's no such thing as absolute motion or rest. Everything in this universe, from the tiniest particle to the grandest galaxy, is in motion relative to something else. This realization, simple yet profound, fundamentally changed how we perceive space and time. Before Einstein, we believed in an absolute space and time, a stage where the drama of the universe unfolds. But the principle of relativity turned this concept on its head. It proposed that space and time are intertwined in a four-dimensional fabric known as space-time. And this fabric is not passive. It's bent and twisted by the mass and energy within it, creating what we perceive as gravity. This led to the birth of Einstein's theory of relativity, a groundbreaking theory that not only confirmed the principle of relativity, but also extended it to include the effect of gravity. It described a universe that was stranger and more fascinating than anyone had ever imagined, where time dilates, space contracts, and the path of light itself is curved by gravity. The principle of relativity also has implications beyond just physics. It shapes our philosophical and existential understanding of the universe. It tells us that our perception of reality is not absolute, but relative to our frame of reference. It challenges us to question our assumptions and see the world from different perspectives. And it's not just theoretical. GPS systems, for instance, that we rely on for navigation, would not work accurately without corrections based on the theory of relativity. It's a practical demonstration of how deeply the principle of relativity is woven into the fabric of our everyday lives. So, the principle of relativity isn't just a fancy physics concept. It's a fundamental truth that shapes our understanding of the universe. So, what have we learned about the principle of relativity? Well, we began our journey by understanding the concept of motion and rest. We pondered over the question, is there such a thing as absolute rest or absolute motion? We learned that all motion is relative and there's no such thing as an absolute state of rest or motion. What may seem at rest to one observer might be in motion to another, and vice versa. Next, we delved into the heart of our discussion, the principle of relativity. This fundamental idea, first proposed in its modern form by the great Albert Einstein, tells us that the laws of physics are the same for all observers, irrespective of their state of motion, as long as they're not accelerating. In other words, there's no privileged frame of reference. The universe doesn't care if you're racing at 1,000,000 miles an hour or simply sitting around sipping tea. The laws of physics won't change for you. Then we explored the profound implications of this principle. It plays a crucial role in shaping our understanding of the universe. It led to the development of Einstein's theory of special relativity, which revolutionized our concept of space and time. It gave birth to the famous equation E equals mc squared, linking energy and mass in a way no one had ever thought of before. It's not just an abstract concept, but a principle that has real-world applications, from GPS technology to particle accelerators. In summary, the principle of relativity is a cornerstone of modern physics. It's a testament to the beautiful symmetry and consistency of our universe. It's a principle that gives us the assurance that no matter where we are or how fast we're moving, the fundamental laws of physics remain the same. Remember, the universe doesn't play favorites with its laws. Whether you're hurtling through space or chilling on your couch, the laws of physics hold true. And that's all thanks to the principle of relativity.